All right, for 97, I'm going to go to the whiteboard. And let's put that down. And let me just get a new whiteboard going here. Push this down. And we're doing 97. I'll write that down for you. 97. Let me get my pen back. Erase this doohickey here. So 97 is a sum, n equals 1, off to infinity. And that's the natural log of n over n plus 2. All right. Now, when we look at this order view, there's a variety of ways of doing it, but when we look at this, I'm going to look at a partial sum. I'm going to call it Sn. Now, when I say Sn, S big N, what's this going to be equal to? It's going to be n equals 1 up to big N. It's not infinite. This is going to be definitely a conversion problem here. What do you get over here? Well, you're going to get the natural log of n minus the natural log of n plus 2. And this kind of reminds me of a telescoping series, but let's see what happens. What do you get? Let's write this down. And it's going to be natural log of 1 minus the natural log of 3. All right, that's the first one. I'm going to take n as 1. Now I'm going to go to n equals 2. Get the natural log of 2 minus the natural log of 4. We go to the next one. It's going to be natural log of 3 minus the natural log of 5. I think you get the idea over here. What's the next one going to be? Natural log of 4 minus the natural log of, well, let's see, 3, 4, 6. Okay, boom, 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 boom. It goes to the end, and the end is going to be the natural log. I'm going to back up from this, by the way. Big N minus the natural log. Let me just remind you what you got over here. It's going to be big N plus 2. Doesn't look like a n plus 2, does it? I want to go backwards. And to go backwards, I'm going to say ln big N minus 1 minus ln big N plus 1. Go backwards once again. ln n minus 2 minus ln of n, then, right? All right. So I think, there's a lot of things that I'm not putting down there. I'm just going to say I can see the pattern to it. Right. So the question is, what does it give me? And I got to be careful. So what I'm going to do over here is I'm seeing that this and this would disappear, that this and this would disappear. I hope you realize there'd be an ln5 over here would disappear. There'd be an ln6. Let's go backwards, though. What do you have here? I see this. All right? And then I'd see this canceling this, so forth and so on. So if I were to look at that, I would say, oh, the sum, the nth partial sum, is going to be the natural log of 1 plus the natural log of 2 minus the natural log of n plus 1 minus the natural log of n plus 2. All right? So I'm looking at that. At least I got an nth partial sum. I could, you give me any n, I'll get the sum to it. But what I need to do now is I need to pull it all together. All right, so I'm going to put Sn down. I'm going to pull these two terms together. This is going to be the natural log of 2. I'm going to pull these two terms together, and that's going to be minus the natural log of n plus 1 times n plus 2. You may wonder what I did there. I factored out a minus 1, and I saw a product there. Okay? What do you get now? Natural log of 2 over, let's see what you get there. N plus 1 times n plus 2. All right, limit as n goes to infinity. Let me just think for a moment. Well, as n goes to infinity of Sn, what do I end up with? Well, if n goes to infinity, the bottom gets huge. 2 divided by a huge number is going to go towards 0. And the natural log of 0 from the right side would be minus infinity. All right? Now I want to just go back over here and see if I did everything I was expected to do before I move forward. Yeah, it said the series diverges. And we're done. Thank you.